Hello everyone, welcome to my channel Chemistry is Fun. In my previous few videos we have discussed about bonding, that is chemical bonding between the different atoms which are present in the molecules. We have seen about the electrovalent bond, which is also called ionic bond. Today we will be discussing about the second type of bond, that is covalent bond. Covalent bond is all about sharing of electrons. Electron sharing has to take place. This bond was proposed by Lewis, and it suggests that there are certain atoms which can gain noble gas configuration by sharing the electrons. Now we will see how it takes place. The number of electrons shared may be 1 or more than 1. That is, the electron pairs which are found between the atoms after sharing may be 1. Then we will get a single bond. It may be 2 pairs or even 3 pairs, resulting in double bond or triple bond. As in case of nitrogen, we see there is a triple bond between the 2 nitrogen atoms in the nitrogen molecule. So here 3 pairs of electrons are being shared. And one more important thing is that each atom of the 2 will contribute equally. Then it is a covalent bond. Means here nitrogen, one atom contributes 3 electrons, the other atom also contributes 3 electrons. So 3 electron pairs are being shared between the 2 nitrogen atoms. So as we have just seen, as in case of hydrogen, we will see it is a single covalent bond. There is a single bond between 2 hydrogen atoms, then it is a single bond. Nitrogen molecule exhibits the example of multiple covalent bond, it is triple bond. The multiple covalent bonds may be double bond or triple bond, as the case may be. Now we see some examples where sharing of electron takes place to form the covalent bond. Now see, this hydrogen represents one hydrogen atom having one electron. For this hydrogen, we are representing the electron by a cross because we want to distinguish and clearly state how the electron sharing is taking place between the 2 hydrogen atoms. So for this hydrogen, by a cross we are representing the electron. For the second hydrogen, we are representing with a dot. Now you see, this is the shared electron pair in this area. This is the shared electron pair. So we see one cross and one dot, that is one electron is shared by each of the atoms. And since it is one electron pair, we get a single bond. This single bond is represented by this dash. So it is H dash H. It is hydrogen molecule consisting of 2 hydrogen atoms. Here you see both the atoms are of the same element. Similarly, we can explain the formation of chlorine molecule. Chlorine is Cl2. That is 2 chlorine atoms form one chlorine molecule. In the valence shell of chlorine atom, there are 7 electrons. The electronic configuration of chlorine atom can be represented as 287. So in the valence shell, you see there are 7 electrons. For this chlorine atom, we are representing it by dots. For the other chlorine atom, which will also participate in bond formation, we are representing the electrons by cross. So you see, before sharing both the chlorine atoms, each of them are having 7 electrons in the valence shell. One electron will be shared by both, which is shown in this common area. You can see one dot and one cross. So here from this chlorine atom, this one will share one electron and the other chlorine atom also will share one electron. So this electron pair is shared by both and it belongs to both. Including this, you see for this chlorine, for the left side, 1, 2, 3, 4, 5, 6, 7 and 8. Octet gets completed. For the second chlorine atom also 1, 2, 3, 4, 5, 6, 7 and 8. So including the shared pair, both of the atoms now complete their octet, thus gaining noble gas configuration. So the purpose of bonding gets solved. Here also one electron pair is getting shared, so it is a single covalent bond once again, which is represented by a single dash. We can see between the two chlorine atoms, Cl-Cl. So it is a single covalent bond forming chlorine molecule. Next is formation of water molecule whose its formula is H2O. But the bonding is in such a way that the oxygen atom is at the center and it is forming two covalent bonds with hydrogen on both the sides. So we represent the electron on the hydrogen by dots and the electrons over oxygen by cross. In the oxygen, in the valence shell, there are 6 electrons. We have represented 6 crosses. And on the hydrogen, the dot represents the electron for both. Now in this there are two bonds being formed by oxygen on both the sides with two hydrogen atoms. Here you see oxygen is sharing one electron and the hydrogen is giving one electron, left side one OH bond. In the right hand side also we can represent, see, another one. This cross representing the electron being donated by oxygen. The dot represents the electron given by hydrogen. So here one more electron shared pair. This is represented by another single dash. So there are two single bonds here, HOH. Next is methane formation, methane CH4. CH4, methane. So carbon will be at the center. Carbon has 4 electrons in the outermost shell. It is not in a position to either donate all the 4 electrons or gain 4 more electrons to complete the octet. So it will go for sharing. We are representing here the electrons over hydrogen by dot, all the 4 hydrogens with dots. The electron over carbon are represented by a cross. So we find that all the 4 electrons over carbon are shared with hydrogen. Thus there are 4 single covalent bonds. Here you see in this is a single pair donated by each by carbon and hydrogen. Like that there are 4 bonds being formed. We can represent all the 4 bonds by dash. So CH, 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 there are 4 single bonds in methane. So these are 4 single bonds, CH, 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 CH. That is CH4 methane. Next is formation of nitrogen molecule. Nitrogen molecule can be represented as N2. It is made up of 2 nitrogen atoms. We are representing the electrons on nitrogen by cross and dots respectively for the 2 different atoms to facilitate the understanding of bond formation. Now we know that nitrogen is having 5 electrons in its valence shell. So in the first nitrogen you see the electrons are represented by square. The second nitrogen we are representing by dots. So there are 5 electrons in both the nitrogen atoms. Each of them are having 5 electrons. So from the first nitrogen 3 electrons and from the second nitrogen also 3 electrons will be shared. So here you see one cross and one dot. These are the electrons being represented by the nitrogen atoms respectively. So 3 pairs are shared in total. See, 3 pairs. So we have a triple bond here. N triple bond N. It is a multiple bond. This is example of multiple bond. It's a triple bond. Though both the atoms are same, the bonding is multiple bond, triple bond. Now in this we see the electron pairs which are shared, they are called the bond pairs. But there are some valency electrons which are not getting involved in the sharing process. They do not participate in sharing, they remain as such, then we call them as the lone pairs. The lone pairs do not participate in bonding. They just remain with the atom only. They are not getting shared. They are the lone pairs. For the formation of covalent bonds, certain conditions are necessary. See, the electronegativity is a very important factor for both the atoms which are participating. Sometimes both the atoms are same, sometimes it may be different. Whatever may be the case, if both the atoms are different which are participating in covalent bonding, we have to be careful about the electronegativity. The electronegativity difference between the two atoms should be very less, or it may be 0 if it is a case where both the atoms belong to the same element, like H2, N2, Cl2. That is, the electronegativity difference should be either 0 or very less. In that case, the atoms will share the electrons and covalent bond formation takes place. Second case is that when the atom is having 5, 6 or 7 valence electrons, then they may share electrons. Sometimes they may gain also, like chlorine, it may form chloride anion, as I discussed in electrovalent bond formation, that is with NaCl. When it forms, it is Cl minus, Na plus and Cl minus. That's a different story. But here we have just seen the example of chlorine molecule, Cl-Cl. So it is having, chlorine is having 7 electrons in its valence shell, and it will share one pair of electron to form single covalent bond. So these atoms which are having 5, 6 or 7 valence electrons, they can share electrons. After sharing, they should get stable noble gas configuration. This is essential. Here also we go back a little and we just recollect once the nitrogen bond formation we have seen. You see, after the bond formation has taken place, the triple bond has been formed. Then if you count the number of electrons pertaining to each nitrogen, it is 8. Its octet is getting completed. For this nitrogen, you see 3 shared pairs means 6 electrons plus 2. So on the left side nitrogen, it gets octet completed. For this nitrogen also 3 pairs of electrons shared, that is 6, plus it is having 2 pairs. This is not getting involved in the bonding, so adding that, it is octet completed again. So after the bond formation has taken place, octet should be complete. Though there may be some exceptions, chemistry is full of exceptions, but today whatever examples we have seen, maybe it's water molecule or methane or nitrogen molecule N2. In all this we see that after the bond formation has taken place, the octet is getting completed. So the main purpose for which bonding takes place is getting satisfied here. So I hope you all understood the concept today, and you must have enjoyed the video, and thanks for watching. Please subscribe to my channel. Thank you all very much.